Okay, this is 1.7 part 4. So in the last video, we talked about having to solve two inequalities at the same time by isolating x in the middle. So that's what we're going to do here. So if I look at this one, it says solve 5 is less than or equal to 2/3 x minus 1, which is less than 19. Express the solution set in interval notation. Okay, first of all, I want to clear the fractions. Okay, so there's only one fraction here, and so the LCD, or the lowest common denominator, is quite easy to find because there's only one, which is 3. So I'm going to multiply everybody by 3. So 3 times 5 is less than or equal to 3 times 2/3 x minus 3 times 1 is less than 3 times 19. Okay, 3 times 5 is 15, which is less than or equal to. Now we get the 3's canceling out, so I get 2x, minus 3 times 1, which is 3, which is less than 3 times 19. 3 times 9 is 27, carry the 2. 2 plus 3 is 5, so this equals 57. Okay, now what we're going to do is we're going to isolate x in the middle. Okay, so to do that, I have to get rid of this 3. So I'm going to add 3 in the middle, but what I do to the middle, I have to do to the ends. Okay, so this becomes 15 plus 3, which is 18, which is less than or equal to 2x, which is less than 53 or 57 plus 3, which is 60. Okay, so my last step is to divide off the 2. So I'm going to get 18 divided by 2 is less than or equal to 2 divided by 2x, which is less than 60 divided by 2. Okay, 18 divided by 2 is 9, which is less than or equal to x, which is less than 60 divided by 2, which is 30. Now I have everything finished. X is isolated. Now I know that my solution runs between the value of 9, including 9, and going up to 30. Okay, so x is sandwiched in between those two values. So it asks us to write this in interval notation. So again, my far left value is 9, which is included. And then my far right value is 30, which is not included. So interval notation, the solution looks like this. Okay, let's look at the next one. Absolute value inequalities. Absolute value is the distinct distance from 0. Remember, absolute values are always positive, right? So no matter what we put into them, it becomes positive, and that's why it's the distance from 0. So if the absolute value of x is less than 2, x can be a negative value between -2 and 0, and it can be any positive value between 0 and 2. In other words, if absolute value of x is less than 2, then x is between -2 and 2, which can be written as, in interval notation, -2 to 2, but not including those endpoints. Or I can write it up as -2 is less than x, which is less than 2. Now, that works for when absolute value of x is less than 2. If the absolute value of x is greater than 2, x can be any negative value below -2 or any positive value above 2. So we write this as x is less than -2 or x is greater than -2, which can be written in interval notation as -infinity to -2 union 2 to positive infinity. All right, so in general, we're going to use the following rules to solve absolute value inequalities. So solving an absolute value inequality, if u is the algebraic expression and c is a positive number. Okay, guys, remember c is a constant. Constant means just a number, okay? And u U has to be an algebraic expression containing x. Remember, C has to be a positive number because an absolute value cannot equal a negative number. Okay? It can only equal a positive number. So the solution of the absolute value of U less than C are the numbers that satisfy negative C is less than U, which is less than C. So when we have the absolute value is less than C, then we're going to write this up like this, okay? The solution set of the absolute value of U is greater than C. These are numbers that satisfy U being less than negative C or U being greater than C. So if we have greater than, we're going to solve two problems. We're going to make U less than a negative quantity of whatever that constant is, and U is greater than C. These rules are valid if less than is replaced by less than or equal to, and greater than is replaced by greater than or equal to. All right, so I want to show you at least one example with this. We have a couple left, so I'll probably do one more video after this, but let's at least get through 1.7.5 A and B. Solve each absolute value inequality, express solutions, and interval notation. Okay, first of all, I want to check this. I have the absolute value isolated on the left-hand side, and I have a positive constant on the other, so I'm good. Okay? Now, I have to determine what to do with it depending on what the inequality sign is. The inequality sign in this case is less than. When that happens, we write this up as such. We take the constant, which is 17, make it negative. We'll do less than. We put 3x plus 5 in the center, less than the actual constant. Okay? So we make it sandwiched in between that negative value and the positive value. Okay. So again, what did I just do? I saw the constant was 17. Because the inequality was less than, I put negative 17 less than whatever was inside the absolute value, 3x plus 5, is less than 17, which was the original value. Okay, now solve for x. Okay, so I'm going to subtract 5 off of both sides. So I get negative 22 is less than 3x, which is less than 12. Okay, now my next step is to divide everything by 3. And I'm just writing this out. So I get negative 22 divided by 3, which is less than 3 divided by 3x, which is less than 12 divided by 3. Okay, so I get negative 22 thirds, which is less than x, which is less than 12 divided by 3, which is 4. And that is my solution. X is isolated. So how do I write this up in interval notation? In interval notation is going to be parentheses, negative 22 thirds, going to 4 parentheses. Okay? So that is my answer. That satisfies that inequality. Okay, let's look at the next one. Just going to put a line here real quick. Okay, so the next problem says the absolute value of 5x minus 2 is greater than or equal to 13. So again, I have my absolute value isolated. On the right-hand side is a constant that's positive. Now, I know I have two problems here. So 2 problems. When the absolute value is greater than, I have to write up 2 problems and solve each independently. Okay, so if you look up above, and I'm going to highlight what I'm looking at here, when the absolute value, let me rewind that. When the absolute value of u is greater than c, I have u is less than negative c, and u is greater than c. Okay, so I'm going to do the u is less than negative c first. Okay, so u, which would be the 5x minus 2, is less than or equal to the constant, which is 13. And remember, I have to make it negative. So there's 1. And then the other one's going to look exactly like what the problem says. Okay? So I have to solve both. Okay, so let me solve both. So I'm going to solve, I'm going to call this number 1, number 2. So I'm going to add 2 to both sides. So 5x is less than or equal to negative 11. Okay? So now I'm going to solve for x. So I'm going to divide both sides by 5. So x is less than or equal to negative 11/5. Okay, I did that one, right? So if I'm going to write this up in interval notation, because I'm going to have to do that, all my x values are smaller than negative 11/5. Okay, so I write down negative infinity to negative 11/5, and I have to include that one. Okay, let's solve the other one. So I'm going to add 2 to both sides. So 5x is greater than or equal to 15. Now I'm going to divide both sides by 5. So x is greater than or equal to 3, because 15 divided by 5 is 3. So if I write that one up in interval notation, it's going to be 3 is the smallest value and the largest value is infinity. So negative infinity to negative 11/5, and including that value, union 3, which is included, to positive infinity is my answer. So when you do a greater than with an absolute value, you're going to get 2 answers, and you need to put the union in between the two. Okay? I'm going to stop here. I'm just going to look back because I'm starting to lose track of what part we're on. Part 4. Okay. So thanks for watching part 4. I'm going to pick up with part 5 that will conclude the 1.7 notes. Thank you for watching, and you got one more left. You can do it.